Hello everyone. So in last lectures we have seen the acidic strength and comparison of acidic strengths of compounds. In this video we will see the basicity and how to compare basic strength of compounds. Okay. So first of all, what is basicity? So according to general definitions, you know that what are the general definitions of a base? So base is any compound which can donate any compound which can donate OH minus ions, right? This is the very general definition of base, but you know that this is not sufficient. So what is the second definition? Second definition, which is important for our analysis, means for our point of view, the important definition is base is any compound which can donate lone pair of electrons. So, for a compound to be basic, what is the most important criteria? The most important criteria is that compound should have an atom which contains lone pair of electrons. Okay, so the one atom which easily donates lone pair of electrons is, of course, you know that it is nitrogen. Because in most of the compounds we will see nitrogen as basic compounds. So see, we know the functional groups like amine, then we know aniline, that is aromatic amine. So you know amine is RNH2, right? So in RNH2, you can see that here on nitrogen a pair of lone pair is there. Okay. So if the structure is such that this lone pair of electron can be easily donated, then that compound can act as base. Okay. So what is the basic criteria? Basic criteria means what are the conditions for a compound to be a good base. So first condition is the compound should have easily available. This is the very important thing. Easily available lone pair of electrons. Okay, lone pair of electrons. So if a compound can easily donate lone pair of electrons, then that compound is basic. Okay, so this is the most important criteria for basic component. And second, what we can say, if suppose nitrogen is present, then sp3 nitrogen can donate very easily, can donate electrons or lone pair of electrons very easily. So we have to find compounds in which specifically nitrogen is present and there is a lone pair of electron present on nitrogen. So I hope you know very well the structure of nitrogen. See, we know the basic concepts and all. We just have to focus on questions which will be coming specifically in semester exams. These questions also come in CSI NET and all exams, competitive exams. But I am specifically focusing on the semester exams. Okay. So in semester exams, all the questions I have solved in these videos or in previous videos, all these questions are the previous year questions of the semester exams of colleges which are affiliated to Mumbai University. Okay. So see, this is a similar question because you will understand better when we solve the questions. Okay. So we will start questions, so you will understand it in more better way. Okay. So see, first question is arranged in increasing order of basicity. So what we have to do? We have to arrange the following compounds in increasing order of basicity. Okay. So first compound is aniline. Second compound is ethylamine, CH3, CH2, NH2. It is ethylamine. Next we have to compare diphenylamine, two phenyl rings and amine. Okay. And last diethylamine. So now we have to compare all of the four compounds. So basically what we have to do, we have to check if the lone pair present on, first we have to check if lone pair is present, because of course if you want a base, then it should be capable of donating this lone pair of electrons, right? So the first condition for a compound to be a base is it should have a lone pair of electrons. So see, you can see in all the compounds lone pair of electron is present on nitrogen. So lone pair is present on the same atom, that is nitrogen. So that condition is satisfied. Second, we should see which lone pair is available for easy donation and which lone pair is not available. So how can we check if lone pair is available or not? So obviously we will check it by resonance or other electronic effects. So see, here in NH2, this is aniline, and we know that in aniline, this lone pair of electrons can go in resonance, right? If you have doubt in resonance or how to show resonance, just tell me, okay? Because I am considering that you know resonance very well, so I am just saying resonance. But if you don't know, just tell me, okay? So see, this lone pair of electrons in aniline can easily go in resonance, okay? Means this lone pair will be delocalized over complete ring. So this is the case in aniline. What will happen in this case in ethylamine? See, here resonance is not possible because there is no pi bond in which resonance can take place. So first, resonance is not there. Second, is there any other inductive effect? Because see here, these are the methyl groups, carbon. Therefore, it will show inductive effect, which will in carbon and nitrogen, which is more electronegative. Obviously, nitrogen is more electronegative. Therefore, here electron density will be pulled by nitrogen. Similarly, here electron density will pull by this carbon because this electron density is being pulled by nitrogen. Therefore, the overall density of electron on nitrogen is increasing. That means in this compound, electron is easily available for donation. So it will be a better base, okay? Now in third case, what will happen? See, here in aniline, only one benzene ring was there in which nitrogen, lone pair of nitrogen were in resonance, and therefore these electrons were not easily available. But here, two benzene rings are present, right? Therefore, this lone pair of electron can go in resonance in this ring. It can delocalize over this complete ring. Similarly, this lone pair of electron can go in resonance in this ring. And therefore, this lone pair of electron can go in any two, means this lone pair of electron is delocalized over two benzene rings. So overall, this presence of these electrons for donation will be lesser than this compound, lesser than aniline, because here lone pair of electron is donated over only one ring. But in this case, this lone pair can be delocalized over two benzene rings. Okay. So therefore, if we give numbers like A, B, C, and D, so we know that lone pair of electrons are available in A rather than in C. Therefore, if we compare only A and C, then lone pair on A is slightly more available than lone pair on C because here two benzene rings are present. Next, in D, if we see, here also nitrogen is attached to C groups and here two carbons are present. This is the on C. If we see only this structure, then it is similar to this. And in this way, there are two rings. Here two carbons are there. Similarly, here two carbons are there. Means in overall, if we compare these carbons and if we compare these carbons, here inductive effect is more. Means here also lone pair of electron is available for donation. Here also lone pair of electron is available for donation. But what is the point of difference? Only A and C. In A and C, phenyl rings are there. That means these two compounds are aromatic amines and these two compounds are aliphatic amines. So what will happen? Always remember, for the case of basicity of aromatic compound, aromatic amine specifically, basicity of aromatic amine will be always lesser than that of aliphatic amines. Okay, so you have to remember this condition. Okay, so when we arrange these four groups, see, the least basic compound will be C because lone pair is delocalized over two phenyl rings. Then second will be A, where the lone pair is delocalized over one ring, therefore it is not available for donation. Now in case of B and D, we have to check. Before that, keep one thing in mind, that we are comparing this means we are doing this comparison solely on the basis of given question. There is a very important concept while comparing the basicity of amines. So I will make a separate video for basicity of amines in aqueous medium and in gaseous medium. The traits are different, but we are just comparing them on the basis of general trends. So it is, we are considering it normal gaseous state. Okay, so you have to consider whenever we are comparing the basicity of amines, then if conditions are given like aqueous solution or condition is given like gaseous state, then the comparison will be means final answer will be different. So I will make a separate video on that. Okay, so for general question we are comparing solely on the basis of inductive effect, that is in gaseous state. So here, as inductive effect of C2H5 will be higher, therefore this lone pair electron will be more easily donated than this ethylamine. Therefore here B will be less available than D. So overall our order of availability of lone pair will be this, and therefore our order of basicity will be this. Okay, so I hope you understood this question. In next question, see, our next question is compare the basicity of pyrrole, pyridine and piperidine. So for that you should know the structures. What is pyrrole? Pyrrole is a 5-member heterocyclic ring containing a nitrogen atom. Okay, so this is pyrrole, where a lone pair of electron is present on nitrogen. Then second is pyridine, which is a 6-member heterocyclic ring containing nitrogen. So this is pyridine, and here lone pair of electron is present. And next piperidine. Piperidine is a 6-member nitrogen containing saturated ring. Okay, so this is pyridine. So if we compare these three structures, see, in for this you can see here nitrogen atom is sp2 hybridized. Here nitrogen is sp3 hybridized. Here it is looking means if we see, it is seen that nitrogen is sp3, but here a second case is there, that is aromaticity. So before going for availability of lone pair of electron, we should know their arrangement. See, first of all we will see in pyridine or pyridine. What is the case here? Here in the ring 1, 2, 3, 4, 5, 6 pi electrons are present. That is 3 pi bonds are present. Okay, and you know that any aromatic compound is more stable than non-aromatic or anti-aromatic compound. Therefore, if there is chance for a compound to be available in aromatic form, then it will be trying to be stay in that aromatic state. Okay, so here you can see in this ring 1, 2, 3 pi bonds are present. And what is Huckel's rule? Huckel's rule is if the electrons are in if any compound contains 4n plus 2 pi electrons, then that compound is aromatic, right? Therefore, if we consider here 6 pi electrons are there. If we put n is equal to 1, so what will be value here? 4 into 1 plus 2, that is 4 plus 2, 6 pi electrons. So whenever 6 pi electrons are present in a compound, it is aromatic. So here, due to these pi bonds, pyridine is already aromatic. Therefore, these two lone pair of electrons are not there in conjugation. That means if they are not in conjugations, they can be easily donated. But remember the condition here, the nitrogen is sp2 hybridized. Okay, so here it is pi bond lone pair of electrons are available, but nitrogen sp2 hybridized. See, in piperidine there is no conjugation, no resonance. Therefore, this pi bond of lone pair of electrons are not in resonance, so they are more easily available for donation. And here nitrogen is sp3 hybridized. And you know the donor ability. What is donor ability? Donor ability means the ability to donate electrons. So whenever sp3 nitrogen is present, it will be donating electrons more easily than sp2 nitrogen due to the electronegativity difference, because sp3 nitrogen will be less electronegative, because here S content is less and P content is more. Okay, so what will happen here? Nitrogen will donate electrons more easily in sp3 hybridized nitrogen, because these lone pair of electrons are not in resonance, plus nitrogen is sp3 which will easily donate electrons. So therefore in this case this lone pair of electrons are easily available for donation. And therefore this nitrogen and lone pair of N can easily react with H plus. Okay, so therefore this is the most basic. I hope you understood this. This is the most basic, because lone pair of electrons on nitrogen are more easily available. In these two cases, see here sp2 carbon is sp2 nitrogen is present. Therefore, lone pair of electrons are available here, but they are less available than the sp3. So, if we give them numbers A, B, and C, then we have got the order that B will be less basic than C. Okay. Now we will just compare where does this A lie. So if you see here 1, 2, 3, 4, 4 pi electrons are present, or we can say 2 pi bonds are present. So according to aromaticity, Ackel's rule, 4n plus 2 pi electrons should be there for aromaticity. And if you see here 4 pi electrons are there, that means this is the rule of anti-aromaticity. So if only these electrons are present, then this compound will be anti-aromatic. But the condition is there should be resonance. So for resonance, this lone pair of electrons should also be in resonance. So if we add these electrons in resonance also, means we make this electron the part of aromatic ring. So see, these are 4 pi electrons plus these 2 electrons. So if we add these 4 pi electrons plus 2 electrons, that is lone pair electrons, so overall the electrons will be 6 pi electrons, and these 6 pi electrons are the following Ackel's rule. And therefore, if the pyrrole ring needs to be acting as, or pyrrole ring needs to be aromatic, then these two lone pair of electron nitrogen should be involved in the resonance. And therefore, if these two electrons are going in resonance, that means they cannot be easily donated. Okay, they are not available for donation, and therefore the lone pair of electrons on nitrogen in pyrrole ring are not available for donation, and they take part in the aromatic sextet. Okay, and therefore they take part in resonance, and therefore the lone pair of electrons on pyrrole cannot be donated. And therefore, if lone pair of electrons are not available for donation, that means the compound cannot be basic, and therefore it is the least basic among all three compounds. So the order will be B is less than C, but A is the least basic. So this is the order of basicity in pyrrole, pyridine, and pyridine. So I hope you understood this question. Next question is similar to this concept, where pKa values of pyridine and pyrrole is given, and you are asked why so. So see, first of all, we have seen that acidity is directly proportional to Ka value. Okay, and this acidity is inversely proportional to pKa value, and you know that acidity will be inversely proportional to basicity. If a compound is more acidic, means it is less basic, and if a compound is more basic, then it will be less acidic. So therefore this will be reversed. So if pKa values are given, it means if pKa is higher, basicity will be higher, and if pKa is smaller, then basicity will be smaller. So see, in pyridine, pKa is 5.21. In pyrrole, pKa is minus 0.27. So in this way, pKa is less in pyrrole. If pKa is less, which will implying the basicity is less. Basicity should be less. And in this question, just now we explained that the lone pair of electrons on pyrrole are involved in resonance or are involved in aromatic sextet, and therefore these lone pairs are not available, and therefore their basicity is highly reduced, and therefore they are very, very less basic. Therefore its pK value is very, very less as compared to pyridine, in which pyridine is also aromatic, but the lone pair of electrons are not involved in aromatic sextet, so they are more available than this. Therefore here pK value is higher, which means basicity is higher, means lone pair of electrons on nitrogen can be easily donated in pyridine as compared to pyrrole. So these two questions are interrelated. So I hope you understood this question. So I will explain the remaining questions in next video, and I will explain the comparison of basicity of amines in aqueous solution and in gaseous solution in separate video. So I hope you understood this question. Then try to practice this question till I upload next video. Thank you very much.